This is a video about section 6.2 and 6.3. Inductive reasoning is collecting evidence, observing patterns, and then drawing a conclusion. So first of all, you have to observe your pattern and check that it's right, and then assume it's true for all cases. So a lot of you might see a pattern in Pascal's triangle. So maybe a pattern that I see is all along the outside, there's a 1. And look, if I keep going, there's 1. So I've saw my pattern and I checked it. The other pattern I see is if I go 1 plus 1, I get 2. If I go 1 plus 2, I get 3. That's another pattern, and I'm checking and it seems to be true. Now I'm going to assume it's true for all cases. So I'm going to assume it's true for this last case. So I put a 1 on the outside. 1 and 5 is 5. 4 and 6 is 10. 4 and 6 is 10. 4 and 1 is 5. And the outside is a 1. So I used inductive reasoning to figure this out. I saw a pattern, I assumed it to be true, and then I went with it. Here's another pattern. Consider the pattern below and make a conclusion. I'll get up my calculator so we can check this. So it looks like I go 1 times 8 plus 1 is 9. 12 times 8 plus 2 is 98. 123 times 8 plus 3 is 987. So it looks like I keep adding one more digit here, and the last digit I add again, and it seems like I keep getting bigger here. I keep adding one more digit here. So my guess is that my answer would be 98765. Okay, that would be my guess. Let's check using inductive reasoning. Let's check if that's correct. So it's 1, 2, 3, 4, 5 times 8 plus 5. Da, da, da. 98765. Pretty cool. Inductive reasoning. And this is something I want you to do. Come to class with this, and we'll discuss. So what you need to do is you need to draw any quadrilateral, so something with 4 sides. Then I want you to mark its midpoints. I actually want you to get out a ruler, get its midpoints, and tell me what type of shape it is. What type of quadrilateral. And as a class, we'll come up with a conclusion. Okay? So right now, you can either stop right now, remind yourself of inductive reasoning, seeing a pattern, drawing a conclusion, and you can do the practice from 6.2. So if you don't want to watch any more video, this is all you need to watch before our next class. If you want to get it done with, keep press and play. Okay? Actually, you don't have to keep pressing play, just don't press stop. So 6.3 is deductive. So deductive means drawing conclusions using logic that is based on facts that are accepted as true. So instead of seeing a pattern, I use strong, hard facts to make a conclusion. And a lot of number tricks are based on deductive reasoning. So pick any number from 1 to 9. Subtract 5, multiply it by 3. And so I want this finished. I want you to do this trick. Do this trick by Friday. Okay? And Mrs. Joe is going to be here Friday, and she is going to go through this trick with you, and she's just going to, you'll write down at the very end an animal's color, country's name, and a mammal. Okay? So you're going to come with a country's name, a mammal whose name begins with that letter. Okay, a country's name and then the second letter, an animal. So for instance, if I chose the country Canada, I could do aardvark because A is right after that. And Mrs. Joe is going to guess all of your animals and your countries is my guess, and its color as well. Okay, so that's the trick that I hopefully will be able to figure out. Okay, here's another, deductive reasoning is used a lot in proofs. So for any two positive numbers, x and y, prove that if x is greater than y, then x to the minus 1 is less than y to the minus 1. So what I'm saying then is that if the numbers x and y, if x is 3 and y is 2, I'm saying that 1/3 is less than 1/2. That's basically what I'm trying to show. Okay? But I'm proving it using mathematical facts, not by patterns. Patterns would be doing a bunch of different examples and then saying that would be inductive, then saying, oh, it must be true. We're using deductive. We're using strong, hard math facts. Okay? So it says, For 1 over x minus 1 over y, the answer will be negative. Okay? Because x is bigger than y. So this is a smaller fraction than this is. So that's just a fact. Okay? Now what I did is I got a common denominator. I times by y over y and x over x. So I have y minus x over xy. So I'm saying since x is greater than y, here I have a negative, and here I have a positive. Okay? Therefore, y minus x over x minus y is negative, meaning that this is negative, because this is just another form of that. And in order for that to be negative, that means that this first guy is smaller than the last guy. So this is an example of a proof using deductive reasoning rather than inductive reasoning. I used hard logical facts, not patterns. Okay, you guys have some questions to try in the textbook. Some of the questions, especially in 6.3, there's one where it asks you to make a 4x4 checkerboard, and it wants you to actually go through and play a game with paper clips and pennies, and I do want you to try that. Even if you leave it to last and find someone in this room to play with, it's a good hands-on experience, and I actually want you to try it. Okay?